Hey Techno Studs! Quite often I see network administrators and network engineers jumping in to start configuring equipment right away without any real thought into planning how things are going to roll out, what the big picture items look like, and what exactly they need to be doing and in what order that they need to be doing it in. And so it can work its way into chaos then because you don't have the big picture in mind. So that's what we're going to do right here in this video is we're going to talk about the big picture. We're going to design our network and start figuring out what our big network is going to look like. And then once we have that big picture in mind, it's a lot easier to adjust for that smaller picture and for creating the individual configurations that we're going to be working with. So let's jump into this. Let's design our network. So in this particular video, what we're going to be covering is that IPv4 address range and what that's going to look like. We're going to talk about the IPv6 address range and what that's going to look like. And then physically, how do we want to connect our different devices to set us up for success? All right, in this course, we want to configure how switches interact together and how routers interact together and how switches and routers interact together. And so we've created this network here that allows us to take a look at these different aspects and configure it throughout the rest of the course. So that's the reason for this setup. But let's create a little bit of a scenario around here. So let's say you have a couple sites. For now, what you have is you have a headquarters site. This is your main office. So this is what your users are actually going to be, or your employees are going to be sitting at these different workstations. Maybe you have laptops, maybe you have desktops, but they're going to be connected to this network. And these are the access switches right here. And this is going to be our core switch for this network. So it's a smaller company from a networking standpoint because we don't have a lot of need for a huge network back here. Okay, and then the other thing we have is we have this other site, and this is going to be our server network. So we're going to actually add some servers over here, and we may grow this over time as well. But our main focus is going to be here and then the communication between these two different sites. And then we have our routers in between that's going to facilitate routing between these two networks and routing out to the internet. So this is our network, and we're setting up for headquarters and a server network here. So when it comes to designing our IPv4 network here, there's a couple considerations. So let's talk about those considerations. First of all, I don't have a set of public addresses for this network. So I'm going to have to use private networking. That immediately narrows our options down to we can use a 10.0.0.0/8 range, or we can use a 172.16.0.0/12 range, or we can use a 192.168.0.0/16 range. So those are our options right there. What I'm going to do for this network right here is use the 10.0.0.0 network. And the reason why I'm going to do that is because, number one, that gives us a lot of ability for growth in the future. We have a lot of addresses to work with. And also, I really like to use this range because I can separate the octets out to organize my network. And I'm going to show you what I mean by that here in a second. But this octet could represent one thing, and then this octet could represent something else. So we're going to talk about how we can organize our network because we're choosing this 10 range. One other consideration is the overlap with other networks that these machines may be in communication with. For instance, my home network is in with this 192.168 range. And so I wouldn't want to choose something that's going to overlap that. So at some point in time, I'm going to connect this network with my home router, and then so these devices can actually get out to the internet. And so we're going to take a look at what that looks like as well at some point in time. All right, so I have these devices all here. I have this IPv4 scheme, And what I'm going to do is I have my headquarters over here. I want to assign a block of a range to this headquarters over here. Then I have my server network right here. I want to assign a block over there. So what I'm going to do is I'm going to assign the 10.1.0.0 slash 16 range. So anything that starts with a 10.1 is going to be in here. And I can have lots of different networks in there. And anything over here, I'm going to assign to the 10.2.0.0 slash 16 range right here. So in here. And once again, I can have lots of smaller networks within there. But this is what I mean by this first octet is going to be representative of the site. So anything that I see 1, I know that it's this site right here. Anything with a 2 is going to be this site right here. And then later on, like I say, we're going to further break this down, and we're going to create multiple networks in here, and we're going to use this third octet in order to represent different networks that are going to be within the headquarters when we start getting into creating VLANs. Okay, so here is my IPv4 scheme here. And then what I like to do is further break this down into, well, I still have these links between the routers right here. So I'm going to assign that, and I've got a little cheat sheet here that I'm pulling up. I'm going to assign that to the 10.240.0.0 slash 16 range are going to be for all of the networks that are in between. And then I want to all of my layer 3 devices, which are going to be these devices right here. And I'm actually going to create this at some point in time, create this switch to be a layer 3 device as well. So I want loopback addresses for those. So I'm going to create a loopback address of 10.241.0.0 slash 16 are going to be the loopback addresses for those machines. So, and then what I like to do is start documenting how this is all going to laid out. And so I'll bring up my little cheat sheet here, and I'm going to show you exactly what I've documented for this now. So IPv4 ranges, I'm going to have the headquarters of being 10.1.0.0 slash 16. My server network is going to be 10.2.0.0. I also like to think about, okay, how is my naming scheme going to be with this? So I'm going to say everything in HQ is going to start with HQ, and all of my equipment in the server network is going to start in with SRV. I may want to shorten that so that they're both just 2 characters. So maybe this is just going to be SV or SR or something to that effect. But for now, I'm just going to keep it as SRV, and anything over in that network is going to show up as SRV. And then I have the IPv4 range for my links between the routers, and then I have the loopback. So now I've got this broken down until I now have defined my ranges there. And then the other thing as I scroll down here is then I'm going to further break down within my network right here. I see a couple devices, and I've got a few switches, different things that I want to admin of this. So I'm going to put the default gateway as 10.1.0.1. It's pretty typical that you have .1 or the first usable address as being the default gateway in this network. So I'm going to say 10.1.0.1 is going to be my router in this case. And then I'm going to get into my admin network. So 10.1.0.11, .12.13 are going to be assigned for the admin IP addresses for my switches. And if you notice, I've actually already got the switches named. So in this case, it's the location dash and then the switch. So I got switch 1, switch 2, and switch 3. Switch 1 is going to be this core switch. Switch 2 is going to be this switch connected to the demo laptop, and switch 3 is going to be the one connected to the demo Pi. And then I've got my servers that are out here. So I might have a demo Pi 1, 2, and 3, and so I got different IP addresses that are associated with each one of those. And then I have my machines. So I'm going to assign a static address of 10.1.0.34 to my demo laptop. Later on, when I have DHCP, I'm going to assign it to a reserved address for 150. And then I have my DHCP range. So I like to separate this out. As you can see, I'm separating out. I have my admin machines. I have my servers. If I had printers on here, I'd have a block for the printers. I have a block for my static IP addresses assigned to the machines. And then I always like to leave a little bit at the end as well. So in case I'm on a piece of equipment, I need to assign a static IP address. I know immediately from 201 to 255 is an open range where I can assign addresses, or 254 rather. I can't use the 255 because that's the broadcast address. But I've got this range where I can statically assign to a machine, so that way I have I can randomly choose something in there and have a relatively guaranteed that it's not something else has taken that. And so I leave a little bit of buffer on there. That works out as long as I only need 150 addresses. So I have 150 address range here for DHCP to hand out. And we're not going to set up DHCP right away, but I'm just planning for the future. So now I've got this kind of set out, and then my loopback addresses are going to be 10.241, and then I'm just going to assign the .1 to this core switch right here, and then .2 to R1, .3 to R2, .4 to R3. So I'm going to assign it to those different machines there as a loopback address, and we're going to use the loopback address for just testing all of this out. So there I've got this broken down now into my different networks and have this big picture in mind of how I want this to work out in the end. So now let's talk about IP version 6. And so what I'm going to use for an IP version 6 is essentially the private addressing for it as well. I'm going to use a unique local address, and the unique local address, I'll start with the FC00::/7. So the first 7 bits of that define what is going to be within my private network here. All right. And so what I'm going to do is break this down very similarly to my IPv4 addresses, just for the ease of remembering everything. So what I'm going to do is this network right here for headquarters, I'm just going to assign to FC00:1:, and then that will be a /16. And then this server network right here is going to be FC002, FC00:2:/16 over here on this side. And then everything that is going to be in a loop back, I'm going to do the FC00:A /16. That's going to be all my networks in between here. And then FC00:B /16 is going to be all my loop back addresses that I'm going to assign to everything. So should be easily to remember A and B and 1 and 2. So it's following a very similar, try to line it up very similar to how my IPv4 address scheme is all lined up. So there you have it. So there I have my IPv6 scheme. So now I do need to record exactly what that looks like. So I've got those recorded right there. And then I have mapped out my network, what it looks like. The headquarters, the switch 1 is going to be ::1. This is actually going to be just R1 for now. So later on, we may do something a little different, but for now, that's going to be R1. And then we have our admin range here for our adminning our different devices. And then we have our servers here that we can set up on our network. Then we have our machine, and then DHCP, we'll get to that in another chapter. We may do that a little differently than we do our IP version 4 because we have Slack. So there you have it. So now I've got my document and my plan all laid out. I have my network diagram, so I know what my network looks like by this this diagram right here, and then I also have my IP addresses all laid out on this. I just used a Notepad document, although I've used things like Excel before, and they've got programs, and I've used Google Docs. So there's lots of different ways we could record this. Notepad is an easy way to do it. All right, now let's take a look how physically we're going to connect these different devices together. And so what I have here is our headquarter office. Our headquarter office is all of our devices within headquarters that we're going to plug together. Now, the orientation here looks a little different than our last diagram that we had. And don't let that fool you though. We have the same equipment and it's all set up pretty much the same in that we have a router here and then we have 3 switches that we're going to be connecting together. We also have our demo laptop and our demo Pi. So it's set up exactly the same. It's just oriented a little different. All right, let's talk about ports. So this router right here is a 1841 that we're going to be working with. This switch right here is a 3750. And these 2 switches are 2960s. So each one of these devices is set up a little different, and we'll take a look at those configurations. All of the fast Ethernet, all of these switches have fast Ethernet ports on it, and those fast Ethernet ports is anywhere from 01 through 48. They also have Giga Ethernet switches and 01 through 2 for the Giga Ethernet interfaces. So these are the faster connections right here. And what we're going to do is we are going to connect then all of these devices together. Let's come up with which ports we're actually going to use to connect them together. So for this router, I like to always put the FA00 towards the outside. It's the first port that comes up here. So I'm going to have FA00 towards the outside, which leaves us FA01 on the inside here. So that's going to be FA01. Next, I need to plug this into the 3750. Now the 3750, I'm calling the core switch, but it's really not going to be the core switch initially. These are all just going to be the same level switches down here, all 3 of these. But later on, we're going to promote it to be a core switch, and that's because it's got layer 3 capabilities. And so that it will come in a future module. We're not going to talk about that right now, but just know that that is the reason why I'm choosing the better switch to be here at the core of it all. Now, I've got to plug this router into the switch, and so I got to choose a port that's going to do that. Now, towards the right side of this device, which is the higher numbered ports, is going to be where my uplink ports are. My uplink are my Giga Ethernet ports. So my Giga Ethernet ports come right at the very end of the switch. And so I'm not going to initially use my Giga Ethernet ports. We're going to ignore those for now, and we're just going to use the fast Ethernet ports. And so what I'm going to do is I'm going to connect this router in those end fast Ethernet ports because it's on the right side of the device. So when I switch it to the Giga Ethernet, then all I have to do is just move it over. And I always like to put whatever is going to be closest to the outside the furthest to the right. And so what that puts us into is FA0/48 is the last port of this switch. So I would plug in FA01 into FA48. I'm actually going to program both FA47 and 48 to be the same. So if I had some sort of redundancy, maybe I had 2 routers, 2 firewalls, or it's plugging into 2 devices that are on my end here, then I would plug them into 048 and 047. So all said and done, we're going to plug this one into 047 with in mind that maybe in the future we have 048 to work with to plug into a secondary device. All right, so that's going to be 047. We're going to plug that into 047. Now, same thing with these switches right here. I want to plug this into what the next last available port is, which would be on this side would be FA0. Well, one less than 47 would be 46. But in the future, we're going to actually plug in two network connections, and we're going to create what's called an ether channel out of those. So I'm actually going to plug this into FA045 on this right here, this switch. And on this one, it's going to be FA0, and then whatever is the last one of this switch, which would be 48, or if you see where I'm going with this, it's going to be, I'm going to actually plug it into 47. And then same thing with this device right here. I'm going to plug this into the next available one, which would be FA044, or I'm going to make 43 and 44 the same. So I'm going to plug this into FA043 on this side, and on this side, FA044, or excuse me, not 44. The last port on this switch is 48, so I'm going to make 47 and 48 the same, so FA47. And once again, I'm setting aside two ports on these switches, and they're right above and below each other. I'm setting aside two because later on we're going to have two Ethernet ports plugged in between each of these devices, so that way we can actually create a faster link between these devices. All right, so there you have it. So there's our ports. Now what I can do is create my document that's going to track all of this. As you can see here, router 1, I'm using FA01, and I'm plugging that into HQS1. Here's a little bit about that naming convention again. HQ because that's the site, and S1 because that's the device. And then on HQS1, port 43 is going to plug into HQS2, port 45, HQS3, and port 47, HQR1. And then finally, we've got HQS2, which is going to be port 34 is going to plug into the demo laptop. That's one thing I didn't talk about, is where it's going to plug into. It could plug into any of these, and we'll probably be switching it around and plugging into different ports. And so I figured, well, you know, my last or my IP address is 34, so I might as well plug it in port 34. Guess where I'm plugging the demo Pi into? Port 21. I don't know. You don't have to do it that way, but it just makes it easier to remember with those. So I'm going to plug those all in, and I've got those recorded. All right. So now what we're going to do in my next videos is then actually start creating the config files to program each one of these devices that are out there. All right, we're ready. We're ready for the next step. We're ready to start configuring this equipment. So we covered IP version 4. We covered IP version 6. We laid out the details. We talked about the port configuration. And now we have our Notepad full of where our connections are at and our IP assignments. We're ready to start configuring. So I'm excited about getting on the next steps on this and configuring our equipment and getting our hands on the equipment and getting something tangible out of this. So we're in a cool spot, and I can't wait until our next video.